Hey, ladies and gentlemen, and welcome to Unit 8, Notes 4-1. So this is actually going to be one of our last note sheets of the unit. So let's go ahead and get started. So today we're going to be talking about solving radical equations. So we've been doing a lot of simplifying, but we haven't actually been doing any solving, trying to get x by itself, telling you what x equals and so forth. So that's what we're going to be kind of working on today, and it helps us to kind of establish why we're using radicals and what it can do to help us. So first of all, let's talk about solving radical equations. So I want you to get these steps written down. So if ever you're on your homework and you're really stuck and you're thinking, okay, I don't know how to do this. Okay, the best thing to do is pull out your note sheets and actually look at those steps. Okay, so for number 1, you're going to cancel the constant on the outside of the radical. All right, so if there's a number being added or subtracted, bring it over to the other side. All right, get that radical completely isolated by itself. That's your goal number 1. Goal number 2 is to cancel the coefficient in front of the radical. Okay, so if there's something being multiplied by the radical, divide it or multiply it away. Again, trying to isolate that radical completely. Next, for number 3, you want to square both sides of the equation. Now, what squaring it does is squaring undoes a radical. So if we square something, it undoes the radical. And last but not least, you want to solve for the remaining variable. So once you square both sides, solve for the remaining variable that's left. Let's take a look at the next one. So a square root equaling a negative number. Here's the deal. The square root of x only has a positive solution. So if we get a radical and it ends up being equal to a negative, then we have no solution. Okay, so if it equals a negative, then we have no solution. So let's go ahead and take a look at some of these. So I'm actually going to have you guys try a lot of them on this video. And the reason being is that going into after the MCAs, you guys are going to be doing another homework sheet on this, and I do want to, because we'll have a day break in between, kind of want to touch back on these. So we'll go over these in class, but I do want you to try them on your own for the time being. So let's go ahead and take a look at number 1. So number 1, we have the square root of x is equal to 9. Well, here's the deal. In order to solve the square root of x is equal to 9, that's hard to see, we need to get the x isolated by itself, which it currently is not. Okay, so we have that radical. We need to get rid of that radical. So I checked step number 1. Okay, step number 1, well, I already have all my constants added to the other side. Check step number 2. Well, I don't have any coefficients for my radical. So I'm down to step number 3, which is square both sides. So what I'm going to do is I'm going to square this side, and I'm going to square this side. Now, I don't know if you guys remember this from my very first notes of this, but when you take a radical like this and you square it, what that does is it just gets rid of the radical, and you are left with just what is underneath the radical. So the square root of x squared is just x. The next thing you're going to do is you're going to take 9 and you're going to square it. Well, 9 squared is 81. So really, x is just equal to 81. I want you guys to go ahead and try number 2 on your own. So just all you're going to have to do is just square both sides. Let's take a look at number 3. So for number 3, we have the square root of x minus 7 is equal to 0. Now notice this minus 7 part is not underneath the radical. So that's where step 1 comes in. We need to get that over to the other side. I want that radical completely isolated on one side. So what I'm going to do is I'm going to add 7 to both sides. So then I get the square root of x is equal to 7. So now this problem is a lot like we just did on numbers 1 and 2. So I can skip step number 2 because frankly, I don't have any coefficients I need to get rid of. That radical is already isolated completely by itself. So the next thing I need to do is I'm going to go ahead and I'm going to square both sides. And by squaring both sides, I'm taking away this radical and I'm just getting what's left underneath. So I get x is equal to 7 squared. Well, we actually want to see what 7 squared is, so we type that into our calculators. And if you're not sure how to type that on your calculator, go ahead and bring what calculator you're using up to me and I will help you do that. So 7 squared is 49. Okay, next, I'm going to have you guys try number 4 on your own. It's just like number 3. Let's take a look at number 5. So number 5, we're going to go through our steps. So first of all, for number 5, we want to check to make sure nothing is added on. Well, if you notice, this plus 4 is underneath the radical. And what number 1 is referring to is more like number 3, when that minus 7 was outside of the radical. Well, we don't have any numbers being multiplied outside of the radical, so we can skip step number 1. Now, step number 2 says to get rid of any coefficients. This 3 right here is considered a coefficient of that radical. Now we want the radical to be completely by itself, so we're going to divide both sides by 3. When we do that, those 3's are going to cancel out, and we're left with x plus 4 And 15 divided by 3 is 5. So we're left with the square root of x plus 4 is equal to 5. Okay, so now we're down to step number 3, which is to square both sides. So I'm going to go ahead and do that. I'm going to square both sides. So I'm going to take this and square it, and I'm going to take this and square it. Now, don't be confused. This is still the square root of this entire thing. So when we square it, it undoes that, and we're just left with x plus 4. Now, don't forget that you need to square the other side as well. That's where students make the most mistakes on this, is they forget to square that other side. So 5 squared is 25. So now what we're going to do is, I'm not done yet. Now, before we were done at this point, but I'm not done here. Okay, I need to solve this completely for x. So I'm going to subtract 4 from both sides. And then I get 25 minus 4, which is 21. So I get that x is equal to 21. Okay, so make sure even if you're squared, that if you've done all the squaring, you're through step 3, make sure you don't forget about step 4, which is solving completely for the variable. All the other problems were solved at this point. So I want you to go ahead and try number 6 on your own. Here are some hints. First thing you want to do is you're going to skip to step number 2. So I want you to divide by 8, square it, and solve for x. So let's see how that goes. Let's take a look at number 7 for me. Now number 7 is kind of an interesting case. So for number 7, we're going to actually have to use almost all of our steps. So again, notice that this plus 9 is not underneath the radical. Because that plus 9 is not underneath the radical, what we need to do is we need to simplify it down some more. Okay, so I need to get that 9 over to the other side. Well, I notice that it's a positive 9. So because it's positive, what I need to do is I need to go ahead and subtract it over to the other side. So I'm going to do minus 9 minus 9. So then I get the square root of 2x minus 3 is equal to negative 4. Now at this point, I have little alarm bells going off in my head. And the reason that I have those little alarm bells going off is simply because that negative 4 is set equal to a radical. Now we talked about at the very beginning of this note sheet that you cannot have a radical set equal to a negative number. Okay, so we have a problem. Okay, if there is a radical like this set equal to a negative number here, that means we have no solution. So we actually don't have to solve any further because we see that radical is set equal to a negative. We can stop. There's no reason to continue because we already know there's going to be no solution because it's set equal to a variable or a negative number. Okay, let's take a look at number 8. So for number 8, I have a similar case as I did in number 7 with that plus 9. Now I have this minus 2. Step number 1 says I need to start by getting that over to the other side. So I'm going to add 2 to both sides. So then I get the square root of 3x plus 1 is equal to 8. Okay, so then I get the square root of 3x plus 1 is equal to 8. So now I'm going to skip all the way to step number 3, which is to square both sides. So I'm going to go ahead and I'm going to do that. So I'm going to square this side and I'm going to square this side. Well, when I square this side, it gets rid of my radical and I'm just left with 3x plus 1. But now I want to set that equal to 8 squared. Well, 8 squared is 64. So this is where knowing your perfect squares comes in really handy. So I'm going to solve for x. I'm going to subtract 1 from both sides. And then I get 3x is equal to 64 minus 1, which gives me 63. And I want to keep solving for x. So I'm going to divide both sides by 3. And I get that x is equal to 21. Okay, x is equal to 21. So some of the hardest part about these is figuring out what steps you need to skip and which steps you need to do. So we'll try and get better at identifying that. Let's take a look at number 9. So for number 9, I notice that there's no number being added outside of the radical. So I just have 5 square root of x plus 1 is equal to 5. So now I'm going to go ahead and I'm going to get rid of that coefficient. So I'm going to divide both sides by 5. So then I get the square root of x plus 1, and 5 over 5 is just 1. So now what I want to do to get rid of that radical is I want to square both sides. So I'm going to go ahead and do that. So I'm going to square this side. And remember, by squaring the square root, I'm just left with what's underneath. So I'm left with x plus 1. And 1 squared is actually just 1. So the last thing I need to do is finish solving for x. I'm going to subtract 1 from both sides. And I get that x is equal to 0 because 1 minus 1 is 0. I'm going to go ahead and have you guys try number 10 on your own. Now, I will tell you on this one that you need to use all of your steps. You need to use all 4 steps. So the first thing you want to do is get rid of this 5 somehow, then get rid of this 3 somehow, then get rid of my radical, and then solve for what's left underneath the radical. And we'll talk about this more on Thursday as well. Next, let's take a look at number 11. So for number 11, I notice that I don't have anything being added on, so I can skip to step 2. Now I need to get that negative 10 away. So what I'm going to do is I'm going to divide both sides by negative 10. Now, some of you may be thinking, hey, Miss Humbert, that radical is equal to a negative. But when we divide by negative 10, negative 60 divided by negative 10 is actually a positive 6. So the radical is actually not set equal to a negative number once we isolate that radical. We're just left with 6. Okay, so then I want to go ahead and now that my radical is completely by itself, I'm going to go ahead and square. So then I'm just left with what's underneath the radical right here. So I have v minus 10 that's left, and then 6 squared is 36. Okay. Last thing I want to do is I'm going to add 10 both sides to solve for that v, and then I get that v is equal to 46 as my final answer. Okay, let's go ahead and do number 12 together. So the first thing, even though this is in a little bit of a different order, I see that 10 there that's being added to the outside of the radical. So the first thing I want to do is subtract that over to the other side. So this is actually a positive 10, so I need to subtract 10 from both sides. And then I get the square root of 10m minus 1 is equal to 3. Okay, so now I notice I don't have a coefficient up front, so I can go ahead and skip step number 2. And I'm going to go next now, and I'm going to square both sides. That gets rid of this square root, and then I have 10m minus 1 is equal to 9. Now I'm going to add 1 to both sides, and I get 10m is equal to 10. Divide both sides by 10, and I get that m is equal to 1 for that one. M is equal to 1. All right, I'm going to go ahead and have you guys try number 13 on your own, and I'm going to do number 14. So number 14, again, your goal is to isolate that radical. We're not adding anything, so I'm going to start by dividing by 9, and then I get the square root of 25. I'm just going to flip it over to the other side because that's what I'm comfortable with, is equal to 10. So the square root of 25v is equal to 10. Now, to undo that radical, I need to go ahead and square both sides. And that squaring motion undoes the radical, so I'm left with 25v, and 10 squared is 100. So the last thing I need to do is solve for v, so I divide both sides by 25, and that gives me that v is equal to 4. Okay. Let's take a look at number 15. So for number 15, again, we have that radical set equal to a negative number. But what's going to happen is we're going to start by dividing by a negative 6. And when we divide by a negative 6, that's actually going to give us a positive. So we have the square root of b plus 4 is equal to negative 12 divided by negative 6, which is a positive 2. So that radical is set equal to a positive number once we isolate it. So there is still a solution. So now, in order to in order to get to that b, we're going to have to square both sides. The biggest thing I want you guys to remember is to not square both sides until you have that radical completely by itself. So once you square it, you're left with b plus 4, and 2 squared is 4, so we're going to subtract 4 from both sides, and that's going to give you that b is equal to 0. Last but not least, I want you to try number 16 on your own. Notice that that radical is already isolated, so you could start with step number 3. Once you're done, show me a completed note sheet, and I will hand you the homework for the next day. Thanks for listening.